Hey everybody, video number 2. Let's get the vocab for the atoms unit out of the way. There's your learning target for this video. I'll be able to define the special vocabulary. So anion, here we go, showing you perfectly gaining an electron. So this is an ion with a negative charge because it's gained an electron. We're going to need to be able to know ion, negative, gained an electron. Those should gain an electron should also be highlighted. Okay. Atom. The atom is the smallest unit of an element that maintains the properties of that element. Comes from the Greek word atomos, which means unable to be divided. Atomic mass. This is adding up the protons and the neutrons. We are going to find in this unit that protons and neutrons do have mass. So the atomic mass is the mass of the two of those. Okay, so it's expressed in atomic mass units. AMUs, we will get away from them quickly and right into grams, I promise. But then we have to talk about moles, so it'll come, but we'll get there. The atomic number is the number of protons. So this is a synonymous piece. You need to maybe put an asterisk here because it's going to talk about atomic number on the periodic table. I'm looking up there. I see the atomic number is the bolded number. Well, what that means is the number of protons. It doesn't say that on your periodic table. This is something you have to learn, you have to ingest, you have to know. Okay, atomic number is the number of protons. A cation, there's that word again, ion. This is going to be a positive ion because he lost an electron, and that picture shows you what's going on. Keep it on that picture and study it if you need to. An ion that is a positive charge because it has lost an electron. The anion, cation, we're getting into positive charge, negative charge. And this is where we're going to get into that. Milks told me hardest math in chemistry is this plus and minus one business. Ionic charge. This is the overall charge of the ion based on the number of protons and the number of electrons and who's winning. Who's winning that game? If protons are winning, protons are positive, so the charge is positive. If electrons are winning, electrons are negative, so the charge is negative. How's that? Pretty easy peasy. Protons, electrons. Here we go. Subatomic particles. This is the subatomic particle with negative charge and no mass, and it's located or resides in what we call the orbitals, which is outside the nucleus. Okay, you just need to know that word, orbitals. We'll get into a little bit more what it is when we get into the videos. Electron configuration, here are some of them. This is the arrangement of electrons in an atom. They do have dashes in between them that do not mean minus. They're just separating energy levels. Okay, so we just say 2,4 or 282. Okay, it's not 2 minus. Periodic table of elements, I like this picture. An element is a unique kind of matter, cannot be broken down by chemical means. An atom is one piece of one element. Okay, we can have multiples, like here, there's multiple atoms of gold here. Okay, it's an element, but there's lots of them here. Excited state, this is when an electron has gained enough energy to jump up. And then we're going to find out that when it falls back to ground, it will release light. So the excited state is giving the electron energy and he jumps up. The ground state is when you see the ground state, excited state, when he falls back down, gives off energy in the form of light. That is our lab. The lowest energy state of the electrons around the nucleus, the normal ground state. The periodic table is all ground state, okay? So normal conditions. An ion is a generic word for any atom that has gained or lost an electron and now has this overall charge. Could be positive, could be negative, because we saw cation, anion, those are specific ions. Any ion, this is a more umbrella term, generic, if you will, any atom that's gained or lost an electron. Okay, isotope, this is a big bad word we need to know. This picture is perfect. It teaches the whole lesson. It is the same number of protons, so the same element, but it has a different mass because it has different numbers of neutrons. So an atom that has the same number of protons, but a different mass number, and you can write in there because it has more neutrons, if you'd like. We will do a whole Bogle on that to make sure you understand it. This is the Bohr model, named after Niels Bohr. It's that planetary model of an atom. And we're going to do that just so we can see the arrangement of these things. And then we're going to move on to the fast notation, which is the Lewis. So a diagram showing the nucleus and all the energy levels and all the electrons. This is a nice map of what's going on. Then we have the neutron. This is a subatomic particle in the nucleus that has no charge but it does have mass. It doesn't say that in here, but it does have mass, so that's key. Neutrons have mass but no charge. Electrons have charge but no mass. Protons, they're king. They have all of it. So I will call them king because they have all of them. Okay, nuclear charge. This is one that messes with people all the time. Nuclear charge, put a little asterisk by this. This again is the number of protons. We're going to find the only two things in the nucleus are protons and neutrons. The only one of those that has charge is protons. So hence the nuclear charge is simply just the number of protons. So atomic number and nuclear charge are code words for number of protons. We need to get that legitimately squared away. This piece in this picture is great. I love this. This is how I was taught chemistry. It's all gone. But this is the arrangement of orbitals via calculus. Yes, I love it. Okay, we don't do that anymore. But I wanted to show you what it would look like in real time. Okay, this is the region of the atom with the highest probability of finding an electron. Yes, they can move around. Protons are king. They are the positive guys in the middle. They got it all. They have a positive charge and they have mass. So they're in the nucleus and they determine the atomic number. There's that code word again, atomic number. That's one we're going to be using all the time. Valence electrons are important. These are that outside ring. So here are Bohr diagrams of a few elements in tables or group 17 going down, getting wider, and the outside ring is the valence. We're going to need to know about them. These are the electrons in the outermost energy level. They determine the chemical properties, and that's all we will be using in these. Next one here, Lewis dots. This is a particular example of a Lewis dot for oxygen. And this is a diagram showing the element symbol and its number of valence electrons. I will teach you how to populate. There's a rule for how to put the electrons around the outside. And I think that is maybe, yeah, done before scanning. Love it. So now you got your learning targets, you got your vocab, and we're well on our way. We got to do a little bit of history, and then we'll move right on to the nuts and bolts of how many of each of these things we're going to find. Let me try again.